All right, so, 37, the motion of a particle is given by x equals 25 centimeters cosine 10t, where t is in seconds. What is the first time in which the kinetic energy is twice the potential energy? All right. This is the one that I'm doing the right one, right? All right, so velocity is going to be 25 times 10 sine 10t. Is that okay? Yep. No, because I'm going to square it in a minute, but I should put the negative in there. And does it matter if I use 25 or 0.25? Probably not. We're just trying to make a relative comparison. I want to know when is the kinetic energy 2 times the potential energy. So I'm looking for the time when this occurs. Everybody good? All right. Now let's move that to the side and go 1/2 m 250 sine 10t squared equals no, I'm sorry, I messed that up. 1/2 m v squared. So, no, I did that right. 250. Sorry. Sine 10t squared equals 2 times 1/2. 2 times 1/2 k. We'll come to that in a minute. K x squared, which is going to be 25 cosine 10t squared. Got everything written there, I think, correctly. So, K, let's handle these little pieces here. We know that this represents our x naught, whatever our initial displacement was. But 10 is omega, which is the square root of k over m. Correct? Maybe all understand why I'm writing that down? So we know that that equals 10. So I'm going to square both sides and get 100 equals k over m, or 100m equals k. I mean, I need to get rid of the m and the k here. And so this is the best way to do it, because I know that whatever omega is had both k and m in it. So wherever I see k, I'm going to put 100m. So this is 1/2 times 250 is 125 m times sine squared 10t. And that equals 2 times 1/2 is 1. K is 100m times 25. Let's just make that 2500m. Cosine squared 10t. I'm doing this fast, so please check my arithmetic. I'm not confident in my arithmetic. My arithmetic okay? Or you had no idea how to do it and they're seeing it for the first time? Yep. The 250 is supposed to be squared and the other 25 is supposed to be squared. So that's going to be outside my ability to use a calculator. I mean, 25 squared is 625 plus a couple of zeros. So that would make this, and half of that. So I don't know. It's going to be 1/2 m 62500. All right. And this is going to be 100 times 25 squared. So that's 62500. No, that's convenient. So boom, 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 boom. Good. Nice. 1/2 sine squared 10t equals cosine squared 10t. Boy, I really hope my arithmetic's right that time, because that's a lot better. So I guess for me, this is going to be tangent squared 10t equals 2, or tangent 10t is root of 2. And you can just find out what t is from there. I'm going with that. I'm sticking to it. I should have expected the numbers to cancel out. But, all right, so that was 37. So 52. 57. The two blocks oscillate on a frictionless surface with a period of 1.5 seconds. The other block just begins to slip when the amplitude is increased to 40 centimeters. What is the coefficient of static friction between the blocks? I would pay strong attention to this question. This is AP stuff right here, for sure. In fact, one of the problems we're going to see as our practice has this on it, except the blocks are stacked on top of each other and are oscillating up and down, and you want to know when one block leaves the other block. Same question. So here I have the spring attached to the bottom block. And there is a top block. Now, we are told that the system is oscillating with a period equal to 1.5 seconds, and we're told that when the amplitude is 0.4 meters, the top block just begins to break friction. So that means at that instant, we are at the threshold of friction. So that means our static frictional force, which would normally be an inequality, is going to transform and be an equality for that instant. Bring that up because it is Hooke's law that moves the bottom box, but it is friction that moves the top box. Does everyone understand what I just said? And my understanding is that friction is at a maximum at the extremes. So my maximum acceleration is x naught times omega squared. I'm bringing this up because if the only force acting on the top box is friction, then friction has to equal m times a max at that instant. We good so far? Everybody follow why I have that there? Yes, sir. Really? Check your notes. The day that I had all the spring things on there, we went through each step, I should have had a moment where I talked about all of the maxes of each one. Does that ring true? Yeah. Okay. I mean, I want to make sure it's there. I wasn't trying to be facetious. I'm sorry. That came off like an ass. I wasn't trying to be like that. I was trying to say, let's see, because I thought I had put it in all the classes that you have this group of things that are all related to omega. And so you should have one there for A max, V max, period, and frequency. So are those all there?
Yeah, period.
Okay. So knowing, and the reason I want to do it this way is because if I do this substitution right now, I can write this as m x naught omega squared. But I was told that the period is 1.5 seconds. Well, period is 2 pi divided by omega. So omega is 2 pi divided by period. You see what I'm doing? So I think I'm seeing a way to kind of work this problem out. Now, there's more to do here. Does this get you guys started enough where I can move on to another one, or would you like me to continue? Because I can continue. Is that good? You will get to the answer pretty straight away after this. Friction is going to be equal to mu mg, so the m's are going to cancel. you'll have mu g in there, and you'll be able to go from there. So right here, mu mg, put that there. You'll cancel out the m's. You have x naught. You have a method for getting omega now. So I think you could get this through. Do you have a question? Okay, so I'm going to move on. I think that's enough. Be honest with me. If it's not, I'll keep going. All right. So, I'm sorry, what was the next one? The pendulum shown in that figure is pulled to a 10-degree angle on the left side, and released. What is the period of this pendulum, and what is the pendulum's maximum angle on the right side? All right, question A we'll handle first, and then we'll do question B. I have this instance of the pendulum. That's where it's released. This is 12 centimeters, and this is 12 centimeters, and there's a peg right there. It will swing until it's straight down. Then the peg only being on one side means that it will go to the other side. And here the length is 24 centimeters, and here the length is only 12 centimeters. It's swinging from this position to the bottom is, from here to here, is 1/4 of period 1. And from here to here is 1/4 of period 2. There are two different periods because there are two different lengths. Everybody follow along so far? Maximum displacement to equilibrium is 1/4 of the period. Equilibrium to maximum displacement is another 1/4 period. It will repeat this pattern on the way back. So 1/4 times 2 pi times the root of L over G plus 1/4 times 2 pi times the root of L over G equals 1/2 of the total period. Now, it has to swing backwards to get the period. So I treat this like it's two different pendulums, but it's only using a portion of its motion during each one of those. I'm going fast, but do you understand the different parts here? Length determines the period of a pendulum. That peg being in the way means that its period is being obstructed. Now, that part's well and good. The next part, not so much. The next part's going to be different than this. So if you understand this, I'll move on. If you don't, I'll explain it more. Okay. The pendulum has to swing to the same height each time if no energy is lost. Does everybody understand that statement? Well, the height on the left side determines this system, and we were told it was 10 degrees. So on the left side, mg L1 minus cosine theta is how much energy it has when it starts. And here L is 12 centimeters. And theta is 10 degrees. That's how much energy it has at the start. It didn't lose any energy, so at the end, mg L1 minus cosine theta must be the same height. These must be equal. But here, L is 24. Everybody following all of this? Because I'm just trying to go fast. So I'm just going to kind of yeet that away and have mg 12 1 minus cosine 10 degrees equals mg 24 1 minus cosine unknown degrees. Cancel, cancel, 12, 2, and I have 1 minus cosine 10 degrees divided by 2 equals 1 minus cosine theta. I'll leave that to you guys. So 75? The two-spring system of number 75. A block in a frictionless table is connected as shown in two-spring having spring constants K1 and K2. Find an expression for the block's oscillatory frequency in terms of the frequencies F1 and F2 at which it would oscillate if attached to spring 1 or spring 2 alone. So we came up with this, didn't we? We came up with the period of oscillation for the two-spring system. So can we refer to that, or do I have to derive that again? I prefer not to. So my recollection, if I'm right here, is that omega for the two springs was K1 times K2 over K1 plus K2 times M. Please check my memory on that. But we did that in class a couple days ago, I believe on Monday. Am I correct there? All right. Now, they want us to express the frequency. So, our frequency in terms of the other frequency. I don't have any magical method to do that, except to recognize that one spring on its own frequency would be equal to 1 over 2 pi times the root of K over M. So K1 for frequency 1. And frequency 2 would be 1 over 2 pi times the root of K2 over M. So, bless you. Let's see, what would be a good way to do this?
Attention staff and students, at this time, just please listen carefully. We have a couple different groups of students that are going to a couple different areas. The first group of students that should be released are all juniors, that is all juniors at this time, and report to the gym. All juniors at this time should be reporting to the gym. The second group of students are the seniors. At this time, all seniors should be reporting to the auditorium for a presentation in the auditorium. No presentation in the auditorium. Seniors at this time.